This is Mrs. Gastler, and in this video we're going to talk about Newton's second law. It's important that before you take these notes that you have finished the second law lab. If you have not done that, go back and do that first, okay? At the end of this video, you're going to be able to state Newton's second law and explain what it means about the motion of objects, okay? So let's start by writing down what Newton's second law says. Now, it's got two parts to it. First, we're going to be talking about the acceleration of an object. The acceleration of an object is directly proportional to and in the same direction as the net force on the object, and it is inversely proportional to the mass of the object. Now that's what you should have seen in the lab. If that's not what you saw, then you probably did something wrong, but that's okay. Hopefully we'll get it to make more sense in your head. You probably did see that anyway. Okay, directly proportional means that they change in the same way. They increase or decrease together. So what you saw in the lab was that when you applied more force, you ended up with more acceleration. And when you used less force, you saw less acceleration. Okay. When we say in the same direction, we literally mean that they point in the same way. So when there was a force in that direction, that was the direction as the acceleration, okay? Whoops, I'm going to draw some same pictures here. This is from Unit 3. Do you remember way back last semester in Unit 3 when we talked about acceleration? So if acceleration and the motion are in the same direction, what does that mean for the force and how it's going to change the motion of the object? So if the motion and the acceleration are in the same direction, that means that the object is probably going to be speeding up. Now we drew motion diagrams. They looked like that. So remember our motion diagram. In this picture, we've got our object moving to the left, and the acceleration is also to the left. That object is speeding up. Now if they're in opposite directions, do you remember what that looked like? Here's one, this orange line here. That object is moving to the left, but the acceleration is to the right. When they're in opposite directions, that means that the object is slowing down, okay? Now, inversely proportional is how the mass and acceleration are related. That means that they are changing oppositely. So if you have more mass, which you saw in the second law lab, then you have less acceleration because that heavier thing is harder to push, right? It's harder to get going. Less mass means more acceleration, okay? So that's what Newton's second law is telling us. It's all about what's going to happen when we push on something, what's going to happen when we push on something that's different, okay? So what can I do with that information? Well, you can explain what's happening when something is changing. So let's say you notice that the object has increased its acceleration. Well, that means that there's more acceleration. So what could have been causing that? Well, either there was more force, just like we saw up here, or there was less mass, okay? So those are the two possible ways that might have happened. We can also predict changes with this information. So what could have happened to the acceleration if the mass is increased? Well, more mass means that we'll have less acceleration. Whoops, there's like a random green dot there, okay? What would happen to acceleration if we decrease the force? Well, decreasing the force means that we will have less acceleration. So that's what we're going to be doing with Newton's second law. So that's how we use Newton's second law, the two different ways that we might be able to do it. So now you're going to have some practice to do on the next page. So if you have any questions about how to use any of these pieces of information here, make sure you ask your teacher. Thanks for watching.